In number 14, it's a pretty straightforward question, but there might be some vocabulary terms that you need to have clarified. The first one is they're talking about the normal freezing point up here of 1-propanol. And you don't need to worry too much about this, but what the term normal means is that it's the freezing point at 1 atmosphere of pressure. So if we know the freezing point is 127 degrees Celsius, then the question is the freezing point of 1-propanol endothermic or is it exothermic? And so the way to think about that might be to draw yourself a particulate diagram to think about what's going on. You'll remember that we envision this phase change going from a liquid to a solid. And a lot of times if you draw the particles, it makes it a lot easier to see. Remember that liquids are spread out and moving quite fast. Solids tend to be very close together, and while they have motion energy, it's a lot less, and they certainly aren't moving much. So if you think about which side has more energy, then you'll probably be able to figure out whether it's gaining or losing energy. Then in part B, it wants to know in what temperature range is the freezing of 1-propanol a spontaneous process. You remember this word spontaneous, it doesn't mean that it happens fast, it means that it happens naturally. So if you want it to freeze, is it going to freeze naturally below minus 127 or above it? And then in C, in what temperature range is it a non-spontaneous process, so it does not happen naturally. Does it not freeze naturally above minus 127 or below minus 127? And then lastly in part D, they want to know at what temperature is the liquid and solid at equilibrium. And so at equilibrium means you have a mixture of these two present all at the same time. And you remember that it's going back and forth and back and forth. So when do you think you have a mixture of those two?